Okay, I'm kind of getting started here in the middle. I started working on another prompt over here to the playground. It's uh, it's a tutor prompt. I've run into uh, just realizing that I'm missing some key foundational concepts for programming, and I think that's why sometimes working through this, having the AI do the programming, I'm lacking some of the foundations to be able to catch errors and make the process more smoother. Here's where I started. Your very advanced tutor teaching aids will be passed by the student and marked /teaching aid, and this is to be interpreted as teaching aid. This does not reflect the student's understanding, but is used instead to be the guiding teaching material. Explain as thoroughly as possible the lesson and ask as many questions as necessary to finally pronounce that the user has gained enough knowledge and understanding to be pronounced proficient in the subject matter. Finally, congratulate the student and pronounce that they have passed the lesson. Limit each of your responses to between 200 and 1,000 words. So I started compiling the teaching aid. I did the /teaching aid, and then I'm using these double colons to separate materials. So these are headings, and then the material that's under them. And I'm working off of this encapsulation and programming from Stackify. So the benefits of encapsulation and then its material that I don't know yet. This is actually a real lesson that I need, and so that's what I'm doing. I'm putting this together so I can understand encapsulation. I have taken this web page from Stackify. It's a really in-depth lesson on encapsulation. I'm assuming that it's good information. We are gonna see. Um, so I've basically pulled it all out, put it into a text document, the contents, and put it into a teaching aid. And now let's see, /command begin should start the tutor process and start this class. So let's give it a shot. Okay, welcome to the lesson on encapsulation and programming, a fundamental concept in object-oriented programming. Introduction to encapsulation. Encapsulation can be thought of as a define the visibility of class members. They include private, only accessible within the class it is declared; protected, accessible within its own class, subclasses, and classes in the same package; public, accessible from any part of the program; getters and setters. These are public methods used to access and modify private data while providing a way to implement data validation. Example code. We are declaring, okay, so I guess that, okay, declaring a public class of person, so this class is accessible from any part of the program. Okay. Public class has a private string of name and a private integer of age. Public person string name integer age. This name equals name, this age equals age. Getter for the name. Okay, it'll return the name with its subcategories. Setter for the name. Public void set name. I don't understand that yet, but we will. Public void set name, string name, and you can, okay, that will public void. Wonder if that empties the name, and then you can get age. You can setter for the age with validation. Okay, I think we're voiding the age. If it's greater than 0, then this age equals age, else system out print invalidate. Okay. In this example, the private attributes name and age cannot be accessed directly from outside the person or class. We provide public methods get name, get age, set name, set age to interact with these private attributes. Okay. Benefits of encapsulation is data protection, keeps data safe from unintended modifications. Increased security, sensitive data can be hidden and managed properly. Code reusability, encapsulated classes can be reused easily. Improved maintainability, changes in the implementation of a class do not affect other parts of the program. Okay, what does data hiding achieve in the context of encapsulation? Okay, well, let's just answer them in order. Okay, so my answers there were the first question, what is data hiding achieved in the context of encapsulation? And I put data hiding achieves the purpose of storing sensitive information by hiding it behind private subclasses, so it can only be accessed by public methods that interact with functions to control or update the data. In this way, sensitive data cannot be updated or lost by external access. And it graded that as you correctly identified that data hiding protects sensitive information by restricting direct access to attributes, which minimizes the risk of unintended modification. This encapsulation principle ensures that any interaction with the data must occur through well-defined public methods, maintaining control over how the data can be accessed and updated. Its second question, why are getters and setters important when dealing with private data? And I put getters can retrieve data from a class but not change it, while setters can change or update data in a class. This can be controlled with validation methods such as verifying that a change the person's age person.age data will result in a valid age. This does not verify the accuracy of the data itself, but it does ensure that only data that is valid can be changed by a setter. And it graded that answer as getters and setters. Your explanation of the roles of getters and setters is spot on. Getters provide read-only access to private attributes, while setters allow controlled updates, which can include validation processes, like ensuring age is not negative. This validation adds an extra layer of security and integrity to the data by preventing invalid values from being set. And then third question, can encapsulation concepts be applied outside of OOP, object-oriented programming? Provide an example. And I put the example given in the lesson is that of a car. One doesn't need to know the inner workings of an engine to be able to operate a car. One must only understand interacting with the controls of the car to operate it, much like data in a class is controlled by the inner workings or functions inside the class. And it graded that answer as the analogy. Your car analogy effectively illustrates the principle of encapsulation in a relatable way. Just like a driver does not need to understand the engine to operate a car, users of a class do not need to know about its internal workings. They can interact with the class via public methods, ensuring simplicity while maintaining functionality. And then it goes, for moving forward, to solidify your understanding of encapsulation, let's consider the following scenarios. So it's got 3 scenarios here that we're going to take a look at here in a little bit. I'm going to take a break and I will be back. Let's get back to this. Okay, moving forward, to solidify your understanding of encapsulation, let's consider the following scenarios. Implementing an encapsulated class. Can you write a simple class that represents a bank account with private attributes for account number and balance? The class should include a method to deposit money using a setter and a method to retrieve current balance using a getter, along with any validation you would deem necessary for these actions. Okay, bank account. Balance 0. Okay, let's see if that's acceptable as an answer. Because it looks like it creates the class. Here is where it instantiates the class and defines the self with account number, making it the account number sent, and the initial balance is less than 0. Initial balance cannot be negative. Self balance, initial balance. Self balance equals initial balance. And then you have a couple of functions to adjust it. You've got a deposit function. If the amount is less than 0, deposit must be positive, and then it adds the amount to self's balance as a private class. Aha, okay. Double underscores here makes account number private and account balance private, so they can only be updated or altered through internal functions inside the class. So you got a function for deposit. It has to be validation has to be greater than 0, and then it adds it to the balance, and then you have a get balance function. So we can only see the balance if it's okay. Private class, so that's why we have a private function to get balance. Okay, let's see if this qualifies with the AI as a one. Okay. Now we know that the AI wrote this, but obviously I do understand it well enough to decide that that's acceptable and put it in for my answer. Great job. Your implementation of the bank account class in Python clearly demonstrates principles of encapsulation. Review the code. It repeats the code. Here's the analysis. Private attributes. By prefixing account number and balance with double underscores, you effectively encapsulate these attributes, preventing direct access from outside the class. This means users of the class cannot directly modify the account number or balance. Okay. And that's the double underscores where we instantiated the instance of this class. Okay, you've included validation in both the initialization method and the deposit method, ensuring a negative initial balance or deposit isn't allowed, reinforces the integrity of the class data. Now, this is something that I wouldn't think of until I needed it for a project, but it's great that we have an AI to write it, and it can throw this out as a reinforcement that we should validate any of our any values we're updating inside of a class. We should validate if possible. Okay, the getter method, the get balance method, permits controlled access to the balance attribute, allowing clients of your class to retrieve information without exposing the actual data structure. That was, let's see, our get balance, return self, again, private balance, and you can only access it through a public method. You can access this class, you'd have to send the account number and yeah, you'd have to send, I believe, at least the account number to get to the balance, to get it to return the balance. Can you think of a scenario where using a specific access modifier could prevent potential issues in maintaining or developing your application? For example, what problems might arise if you had used public attributes instead of private ones in the bank account class? Easy enough. Okay, feel free to elaborate on your thoughts. Once you've answered, we can discuss the significance of encapsulation further. After this, we can move on to your last question about real-life applications of encapsulation. Okay. And here's how I answered that question. Can you think of a scenario where using specific access modifier could prevent potential issues in maintaining or developing your application? For example, what problems might arise if you had used public attributes instead of private ones in the bank account class? Okay, and I put the access modifier for account number keeps the attribute private, so a user could not accidentally change the account number, so a customer could lose access to their account, or a balance couldn't be changed to a customer ended up with more money than they had. And the assistant goes, exactly. Your reasoning is spot on. Let's break down the points. Protecting the data integrity. By keeping the account number attribute private, you prevent any accidental or malicious changes to it. If this attribute were public, users might inadvertently assign it a new value, leading to potential confusion and loss of access for the account holder. And then preventing fraud and errors. Similarly, if the balance were public and could be altered directly, it could lead to significant issues. For instance, a user could set a balance that does not reflect reality, which might enable unauthorized transactions, create confusion in account records, or lead to financial discrepancies. Okay, the role of access modifiers. The use of access modifiers in classes helps enforce the rules regarding how data can be accessed or modified. Here's how encapsulation plays a critical role. Encapsulation through private attributes. As you pointed out, it maintains control over sensitive data, reducing the risk of unintended consequences. Then controlled interaction. By using public methods like deposit and get balance, you allow for safe interactions with the attribute class. This means that any changes will be validated before being applied. And then moving forward to real-life applications, let's tackle the final question. Encapsulation in practice. Think of a real-life application like a software application where encapsulation could enhance security and maintainability. Describe this application and how encapsulation would be beneficial in that context. Take a moment and reflect and respond, and then we'll wrap up the lesson with your insights and potentially any additional questions or discussions you may want to have. Okay, fantastic implementation. Let's go over user account class and highlight its strengths. All right, so the analysis is private attributes. The use of double underscores, account number, subscription valid, subscription end date ensures that these sensitive data points cannot be directly manipulated from outside the class, thereby enhancing security. The private methods, like generate the account number, validate subscription end date, and update subscription status. They're private, hiding their implementation details. This encapsulation means users of the user account class interact with a well-defined public interface without needing to understand the internal workings. And that's why we set up the private attributes. Validation logic. Included validation methods to ensure that the subscription end date is not only correctly formatted but also set in the future. This preemptive check protects against invalid data entry. The controlled access, the set the subscription end date and subscription valid and get subscription end date methods provide controlled points of access to interact with private data. These methods can maintain the integrity of class data while moving users to perform necessary actions. Conclusion of the lesson, your implementation of the user account class effectively demonstrates the importance and application of encapsulation in coding practices. You have shown solid understanding of how encapsulation protects data integrity and enhances security. The ability to apply this principle in a practical scenario relevant to software design. Critical thinking in identifying the benefits of encapsulation for data and operations. And then the congratulatory note. Congratulations, you have successfully demonstrated proficiency in the concept of encapsulation. In programming, your understanding is now solidified. You have effectively applied these principles through theoretical and practical examples. Well done on passing this lesson. If you have any further questions or topics you'd like to explore, feel free to let me know. I made a video of this lesson with the tutor system prompt. Write a brief summary for the end of the video. And the AI comes back with, in this lesson, we explored the crucial concept of encapsulation within object-oriented programming. Encapsulation involves bundling data and methods within a class, creating a protective barrier that preserves data integrity and enhances security. We discuss how data hiding works through the use of private attributes and the role of access modifiers, ensuring that sensitive information is safeguarded from unauthorized access. We demonstrated encapsulation through practical examples, including a bank account class that restricts direct manipulation of account information and a user account class that manages subscription status securely. Both classes utilized getter and setter methods to provide controlled access, showcasing how validation enhances data integrity. By understanding and applying encapsulation, programmers can create robust, maintainable, and secure applications. Thank you for joining this lesson. Don't forget to like and subscribe for more insights on programming concepts.